Welcome to our parallel session number 1 for stream Perfecting Project Delivery through Superior Planning and Design. My name is Stephanie Wanulok and I'm the Honorary Secretary for the AACE Malaysia section.
Thank you, Steph. My name is Isnin Sunik. I am the Honorary Auditor for AACE Malaysia sections. The next presenter is from Singapore. He is an industry consultant and solution specialist with the SOC system and has been involved in different projects in energy, process and utilities, shipbuilding and construction industries.
Please give a warm welcome to Mr. Hiroyuki Takeshita for his sharing on project lifecycle and operational excellence driven by digital twins.
Hello everyone, my name is Hiroyuki Takeshita from Dassault Systèmes. I've been in Dassault Systèmes almost 10 years, and throughout my life in Dassault Systèmes, I've been working for the customer in the energy and process and the utility industries. And even before joining Dassault Systèmes, I've been working in one of the EPC company in oil and gas sector more than 10 years. So throughout my job career, I explicitly working for the this industry, plant business. Today in my presentation, I'd like to discuss about the digital twin in context of the project life cycle and how the digital twin technology contribute to the operational excellence of the owner operators. The definition of the digital twin is given in this slide, but the value or the definition of the digital twin in the operation and maintenance is relatively obvious. But for the EPC company or the project teams of the owner operator, how it is relevant to them, that is relatively unclear. So in my presentation, I'd like to make this point relatively clear. So to start with, I brought this the annual report coming from the high pressure gas the Safety Institute of Japan. The graph is showing that the starting from the 2001, the blowout and the leakage is in uptrend. So this is the industrial accident is increasing likewise this, and the major cause of that is said to be the capital facility is start aging. And then the uptrend is said to be much worse than before under this COVID-19 situations. And more than ever, the industry is expecting the digital technology contribute and improve this situation. So in fact, some of the countries are encouraging the owner operator to invest on the digital technology. Here we have the one of the example coming from the Japanese government, which is the Ministry of the Economy and the Trade and the Industry, which is called the Super Certified Plant System. So the Japanese situation is on top of this aging facility. The workforce is also start aging, and then for that situation, the government expect the digital technology contribute, the shown here. So there are many topics, but in general, the government expect the digital technology to collect the big data of the asset and operations and analyze the big data and foresee the future and give the hint to the people and also to avoid the mistakes. And from the maintenance perspective, the maintenance practice is to be changed from the corrective maintenance to the preventive maintenance. And then not only giving the encouragement, but also the government is giving the incentive to the owner operator when the owner operator is certified as a super certified plant system. The owner operator is entitled to decide the maintenance the intervals by themselves within the 8 years. So obviously, the longer the maintenance intervals impact overall the project, capital project, the life cycle of the finance a lot. So from the corporate viewpoint, many of our customers is aiming at the operational excellence. And in our industry, the operational excellence can be broken down into the three major pillars, which is the safety and the efficiency and availability. The safety is obvious, it's a #1 priority. And in our industry, our facility is the handling high pressure and also the toxic materials. So ensuring our the employee and also the contractors and the local residents' safety is far more important. And also, as the history says, some severe accident will push the corporate, the company's sustainability at risk. And the efficiency, we produce the more product with less material and less energy, then we can make our facility competitive in the market. And in the availability, in the super simplified manner, our business is to put huge amount of the money upfront, and then after that, day-to-day facility is bringing the return. So we want to keep the facility up and running as much as possible, and we want to operate the plant as long as possible. So digital twin is to contribute to these three pillars: safety, availability, and efficiency. And I listed all the expected the feature and the functionality in this slide. So if we want to say our facility is safe, our design drawings and document are all in compliance with the regulatory requirement and also the functional requirement as well. And we have to ensure that the physical facility in front of us is in compliance with the design and also indirectly to the requirement as well. So throughout the life cycle and throughout the changes, we have to ensure that this, the consistency is ensured, and all the calculation and the simulation, the proof that our facility is, the integral as well. And then we have to keep the operation and the maintenance history. And for the workers' safety and the industry safety purposes, we expect the digital twin allow us to simulate and plan the construction and the major maintenance, major modification activities. And for the efficiency purposes, the process simulation and the energy simulation are to be integrated, and then allow us to optimize the plant operations. And as the information sources are dispersed, and we need to integrate all the existing systems, and that helps the plant operator to make a decision much quicker and easier and in the correct manner. And then very often the digital twin is said to be the 3D viewer integrated with IIoT technology, but this is not only the definition, but we have to cover everything that I discussed. But of course, this is one of the important points. Real-time status visualization is nothing but IIoT connection, and all the corrected data should be processed and used to foresee the future accident. So to realize such a digital twin, we need the powerful engineering platform which covers like modeling and 3D visualization, 4D simulation, and also the configuration management and the change management, and integrate all the external systems, including the IIoT, and then the process of data, and give us the opportunity to foresee the future. And then they integrate the simulation, process simulation, and the energy simulation all together, and then try to optimize this, our plant and the facility more efficient. So the digital twin is not just a standalone, but this is to be positioned amongst the plant operation system stacks. We position it in the level 3 in the ISA 95 plant operation system stacks. And in the typical integration, the digital twin should be in between the enterprise asset management and also the process history. And one of the example of the use cases would be something like, in the field, we may have some the malfunction or some abnormal condition, and then this is to be reported against the enterprise asset management. And then if we need, it will trigger the engineering assessment in the digital twin, and in the digital twin, we refer to all the relevant information, datasheet and document and 3D model, and also the operational information coming from the process history. And then we design the changes, and we design how to implement it, and then it will trigger the work order in the enterprise asset management, and keep update. The plant master data is up to date. So on the other hand, there might be other scenarios where, like it could be driven by data. I mean that in the process history we keep the historical operation data, and then based on that we can the process the big data and analyzes, and foresee in the future which equipment may fail, and then for that we can design the preventive maintenance, and then we can trigger the work order in the enterprise asset management. So likewise, that the digital twin should be in between as part of the plant operational system stacks, and once this digital twin is in as a part of the plant operational system stacks, our way of executing the project will be the changing like this. And even in the plant digital twin, the EPC company or the project team of the owner operator should capture and collect and generate engineering information, and also the plant breakdown structure, I mean that facility configuration information, in compliance with the regulation. As the digital twin is part of the plant operational system stacks, we don't have any more of the handover. As it's part of the plant operational system stacks, the data stays there, and then just the shift the phases from the EPC to operation and maintenance. And then not only that, but during the commissioning phases, based on the facility configuration information and also the regulations, the project teams can define the test cases for the commissioning. Of course, it is to be in compliance with the regulation and also the functional requirement. And then once the test cases are defined well, it is to be packaged, and the schedule and the plan, how to execute, and then the test result coming from the field is the evidence for the completion of the commissioning itself. So not only that, but from the enterprise asset management perspective, particularly in the very rigorous industry, likewise the nuclear industry, the inspection requirement in the enterprise asset management is to be exactly equal to what we define and what we execute during the commissioning. So the test cases in the digital twin should be copied into the enterprise asset management, and then after operation, enterprise asset management should keep track of all the inspection record, and then of course the first result of the inspection is nothing but which we have in the commissioning databases in the project digital twin. So likewise, this this new way of the digital twin is significantly enhanced the data handover, improve the data handover the effort. But not only that, but when the physical facility is up and the ready to start up, the digital information is also ready to start up. And then in this picture, I'm showing what we discussed in another way. So throughout the plant life cycle, as a part of the digital twin, the capital facility information stay as the core of that. And in the engineering phases of the new construction or the major modification, to update and also the engineering information, we should start the engineering application on top of that. That information could be utilized for the planning and the simulation purposes for the construction and the fabrication phases. And then that information, once the plant is moving into the operation and the maintenance, the part of the plant operational the system stacks. So likewise, that in the digital twin should stay throughout the life cycle of the facility, and the stay like the twin of the physical twin, starting from the cradle to the grave, and we don't have any more the data discontinuity. So to close out my presentation, before I close out my presentations, I would like to show one of the typical or the example, the use cases in the demonstration. But before I show demonstration, I would like to highlight the 3 key points here. So the first 4D differential, the digital twin is not just the 3D viewer, but throughout the life cycle of the facility, the site configuration 3D representation is continuously changing. So if the operational personnel want to see in past at some point of the time, so how my facility was look like, the digital twin should be able to answer. And also not only the 3D representation, but to support the decision of the maintenance and the inspection personnel, we should model the resources and operation, and the digital twin should answer in past at some given point of the times what was the situation and what modification and what inspection are made and what was the result of that. And as the digital twin is now the part of the plant operation system stacks, the digital twin should have the capability to integrate all the legacy system around the digital twin. So these are the 3 the key points I would like to highlight here. So and then as the most of the capital facility is aging, so it is not surprising the 3D digital the representation is not available. But here what we recommend and propose is not just put the huge money up front and try to capture everything in one shot. Rather, we recommend the overall the 3D acquisition, 3D the representation acquisition effort into the pieces of the campaign, and for each of the campaign, within the available budget, we define, okay, so this is the scope, or this is the area, this is the floor, and then the progressively we can grow the 3D digital twin. And meanwhile, while this 3D representation is growing, you may have the major and minor modification. In that cases, for the modification purposes, you can model and you can plan and simulate in the 3D, and then that 3D it could be brought into the digital twin. Likewise, that throughout the life cycle of the digital twin, the 3D representation would be growing, and in the end, you would have the perfect view of the digital twin. Okay, now I would like to show how this digital twin looks like in the demonstration. In these demonstrations, on the upper part, we have a calendar view. And here we show that in past what happened and what work order is executed and what operation and the activity took place. And For the lower part, we can see the 3D representation. And if we slide in the calendar back and forward, you will see that 3D representation is changing. And in the beginnings, we just had the first floor of the point cloud, but later we got this second floor of the point cloud as well. Means that in the beginnings we didn't have the 3D representation for the whole plant, but later we got this second part as well. And now we are choosing one of the work order, and then the relevant resources and the relevant facility is highlighted, and the IIoT data is captured and overlaid. In these cases, we are highlighting the people, and the people profile is coming from the external ERP data sources. And these days, many of the customer is thinking about the GPS and the real-time location system, and we know that at some given point of the time, so these people are where that he's working here and there. So this information can be captured. And also, if we highlight the facility side, all the relevant information coming from the document management system and the IIoT could be available through the digital twin, and then this information can be utilized for the 3D colorizing. Likewise, the green is within the normal operating range, and red is exceeding the operating range. And also, in past, what maintenance is executed, that information can be available like here. And also, if the everything can be captured through the 3D, that's good. But unfortunately, for example, some intruder, like suspicious people coming in. So unfortunately, it is difficult to capture as a laser scanning. But if we place the CCTV in your facility, and we can overlay such the video coming from the CCTV as well. And then if you have the drone, and if your site rule allow the drone fly over your facility, you can even capture this trajectory of the drone, and also all the video captured from the drone as well. So likewise, this in the digital twin, the objective is in the digital twin. We know that in past what happened and what is happening in now as well. So before I close out my presentation, here is some of the key takeaway. I have the 5 great points. The number one, digital twin is to contribute the operational excellence in terms of the safety and efficiency and availability. And the digital twin is to comprise this, the following element. To contribute and to achieve this, the operational excellence. First, the basis of the permission and the licenses, and the construction and the maintenance simulation, and for the efficiency purposes, it should integrate the process simulation and the energy simulation. As all the information sources are dispersed, we need the data integration capability, and real-time status visualization connecting to the IIoT is not single the functionality expected from the digital twin. It's just a part of that. Of course, it's important. And then we need data processing the capability to foresee the future, what is going to happen in the future. And then the digital twin is to be positioned, it's not the standard alone, but it is to be positioned as a part of the plant operational system stacks. And then the digital twin digital twin project data is to be captured and aggregated throughout the project lifecycle phases. And in the end, the digital twin project data is to be shifted through the commissioning to the operation and the maintenance without intermittent handover anymore. So it is to be, the continuous digital continuation. And that is all about my presentation. And if I could answer the first question, how the EPC company and the project team of the owner operator are concerned with the digital twin, my presentation was successful. Thank you for listening.
That was a really interesting session on project lifecycle and operational excellence driven by digital twins. Isnin, I'm wondering whether this rung a bell for you.
Yes, Steph, I wish I have my own digital twins doing most of my work now.
Technically, we are digital twins right now. And now we go on to the Q&A segment. Only 1 or 2 questions will be chosen from the chat box for our speaker to answer, and the rest will be attended to within the next 3 days.
Okay, there's a question from the audience that reads as follows. What is your view on companies and organizations that remain resistant to adopt digital transformation? Do you think they can continue to survive?
So in my understanding, the most of the company, we don't see much of the resistance from the people about the digital transformation. So of course, some customers are very aggressive and some customers are very slow, but it's not just a matter of the view on, or the attitude against the digital transformation, but it's just kind of the characteristic of the company. So the aggressive company is the aggressive for anything, and the careful customer is the careful for anything. But in our understanding and in our view, the most of the company embarked on the digital journey, and they started the more or less. Some company has the huge progress, and some customer are carefully investigating what we can do. But the most of the company has understanding the importance of the digital transformation, and they have the more or less some plan or the roadmap or vision.
And now the randomly selected question from the floor with me goes like this. How does artificial intelligence, augmented reality, and virtual reality fit together with a digital twin?
All right. For me, the digital twin and AR and VR is kind of the two sides of the same coin. And then for the AR and VR, of course, we need a complete digital twin. Otherwise, they cannot deliver anything. But on the other hand, for digital twin to deliver the information to the users in the intuitive or in the meaningful way, we need the AR and VR technology. So many of the company, they start thinking about like a remote operation. In some use cases, the company want to operate remote site from the headquarters, and then the other cases, sometimes the site is in the severe condition, and they don't want to dispatch the people to the site as much as possible. So for the expert in the headquarters, they need the experience the site without physically visiting the site. But on the other hand, from the people in the site, they need expert knowledge on their hand in the intuitive way or meaningful way. For that purposes, for that perspectives, VR and AR is essential for the digital twin. And the AI and digital twin is also the kind of the dispensable each other. So for the AI, we need the single point where we can acquire all the information, which could be analyzed, and then predict what is going to happen in on my site in near future. So from the artificial intelligence or AI perspective, the digital twin is a source of information. But even for the digital twin, we need the process, the information, and the deliver the meaningful information for the plant operational personnel. So AI is a tool to the process the information. So as we discussed in my presentation, the current industry challenge is aging facility and aging workforces. So I believe that digital twin and AR and VR and AI is kind of the essential or indispensable for the the industry.
Thank you, Mr. Takeshita. We now reach the end of session number 1 for stream Perfecting Project Delivery through Superior Planning and Design.
We hope to see you again in the next session after the networking and engagement session. Have a good lunch. Thank you.
Thank you.